4 mysterious fast radio bursts are shaking up what astronomers think they know about this very interesting topic. It's today's Talkin' Science Story of the Week.
Across Apple Podcasts, Spotify, Google Podcasts and YouTube, this is Talking Science with Dr. Brad Tucker and Matt Miller.
We featured this last week as well, Australian astronomers leading the world in scientific research. Another discovery is fast radio bursts, and we've talked about these a little bit, I think, in the past. Glenn Nagel from the Canberra Deep Space Communication Complex will be on Monday next week to talk about Parkes' contribution to FRB discoveries. But there are 4 of these little signals that are throwing what scientists thought they knew in the trash can.
Yeah, we've definitely talked a lot about this, and in fact, last week we're trying to find the missing matter. And so the question is, where do these fast radio bursts come from? How are they created? And there's lots of theories that have come about, and one was they're somehow involving a supermassive black hole, either star orbiting around it, material falling into it, and as it gets near the black hole, the gravity of the black hole rips it apart, spits it out, releases a burst of energy, and it would be fairly quick. However, this recent study was able to pinpoint the locations of at least 4 of them, and all 4 did not occur in the center of the galaxy. So supermassive black holes essentially are always in the center of the galaxies. That's where they reside. That's how the black hole in the galaxy comes to form. So if it's coming from not dead the center where the black hole is, then it just doesn't involve a supermassive black hole, because even if you'd say maybe there's another black hole in there, well, there are other black holes. The supermassive black hole, if there would be another big one, would have already coalesced in the middle, unless for some reason you happen to see its emerging galaxy system, 2 galaxies colliding. But then you would see 2 separate galaxies. So it kind of rules out one of the more used or potential explanations of fast radio bursts.
Now, while it's estimated that several thousand of these bursts happen per day across the entire sky, the fact that they're very brief, lasting only several milliseconds, it is an incredible achievement to find these things, to tune in and listen to these things across the sky.
Yeah, you're looking for something that ultimately sounds like a glitch for not even a fraction of a second, and you have no idea where it's happening, where it is, the exact frequencies. It is beyond trying to find a needle in a haystack. It's like if you're trying to find a needle on the planet Earth and, you were blindfolded and then told to go to Mars to look for it. It is that hopeless almost to try and find it. Yet they do, because of the instruments they have built. And it's very successful instrument at trying to find this. And so that's kind of been one of the successes, not only finding more of them, but by finding more of them earlier on, getting a lot of that extra information to try and understand some of the nature of what's going on here.
The most famous fast radio burst is FRB 121102, and it's unusual because it's been detected a few hundred times, I'm ready for my pun here, Brad, since it first burst onto the scene in 2014.
That's right. It's a repeating burst. And so people are starting to think, well, maybe there's 2 different classes of these, the ones that repeat and the ones that do single go-off events. And still, either way, by pinpointing that it's not in the center of a galaxy, it does show that it's probably not a supermassive black hole. Now, something we talked about a couple of months ago, there was a strong periodicity. So, there was an orbit to it, and it kind of happened. There was a pattern that happened with this repeating one, at least, on the scale of every so often days that they were able to detect. And that gave a clue that maybe involved 2 objects. When 2 things spin around, they have an orbit, they spin around at a very regular time. Think of our year, or think of the moon, anything like that. So that would involve potentially a smaller black hole. So it even gives a little bit stronger evidence to that scenario involving 2 objects orbiting around, because these things, at least the ones they've discovered, are not occurring where we think the supermassive black holes are.
And given that these fast radio bursts are coming from so far away, is this sort of our indications of the early universe?
So these are occurring relatively far, but still nowhere near as far as the early universe. They're occurring far away, but that would still be kind of in the middle of the universe. What it's telling us, at the very least, is that in the activity of the middle age of the universe, with these things that are whatever they are and whatever they're doing, there's a lot of activity. So it has to be something that has produced enough stuff, stars, black holes, whatever, to be abundant to be able to be found. But also, as with last week, because they occur so far away, if you can find a way of using them to measure the things in between you, you can get a good understanding of the stuff that we can't see. And that was kind of one of the cool things of trying to find this missing matter, as we covered last week. Just as we use supernova, stars that explode in our visual, to measure how fast the universe is growing, or we can use AGN and the light coming from black holes to measure the size of the black hole. By seeing something big and powerful over different distances gives you a real good scale of just measuring what's in between you and it, which is trying to measure properties of the universe. So really great secondary use of these objects.